Hi, this is Mrs. Clark, and welcome to my video on function notation. So first we're going to talk about what function notation is and how it looks, how you say it, and then we'll talk about how to use it. So we're going to start in this box up here. So function notation is a way to show which function you're using and what input you're using and what output you're getting. So usually a function will look something like this. This f parentheses x is function notation. And what this means is that we're using the function f, and what we're going to put into it, its input, is going to be what's in the parentheses here, which in this case is x. And what you get out of it is your y, and that's what's going to show up on this side of the equal sign. So when I read this out loud, it says f of x equals y. So something goes in to the function as the x and comes out as the y. This is the function that we're going to be using. As you can see, it's labeled f, so that's how I know this is the function I'm going to use, because this is the f function. And the f function says, do 4x minus 9. And so what that means is, this means I'm going to do 4 times my x. And my x is going to be whatever input they tell me. And then I'm going to subtract 9 from it at the end. So you can do a whole bunch of different x's, put them through this function, and have them come out as whatever the answer is when you calculate it. You have to understand how the notation works so you know what the question is asking. Mathematicians really like to do something in a very simple, concise way, so they've developed different notations for things like functions. So what we're going to do is we're going to work on evaluating functions. So we're going to look at this section up here. So it says use your function to find the following, then write your answers in the table. So if you notice, our table has a bunch of inputs and outputs, and each of them are paired up together. So we have to take an input, put it through the function, get out what the output is. We're going to do that for 4 different pairs, 4 different inputs, and get 4 different outputs that match with them. And so what that means in short form is, if you look over here, we have this f parentheses 0. So f of 0, how you would say that. Since the 0 is in this parenthesis, which is the same place that x is over here, or even x is down here, that's telling you that your x is going to equal 0. And so what that means is I have to replace every x in the function with 0. So this little notation, f of 0, is telling you replace an x with 0, every x that you see, with 0, and then calculate out what that is. So when I go through and look at this function, 4x minus 9, I'm going to rewrite it, but instead of x, I'm going to put a 0 in a parenthesis. And what that's going to mean is I'm going to take this function, which was like the shell function, 4 times my input minus 9, and I'm going to put 0 in for the input. Then I'm going to calculate what actually that is. So what is 4 times 0? Well, that's 0, because 4 times anything, 0 times anything is 0. And then I have to subtract 9. So 0 minus 9 is negative 9. So when I have my f function and I put a 0 into the function, out comes a negative 9. So that is now an x and a y pair that go together. So when I put 0 in the function, out came a negative 9, my input and my output that go together based on this function. In the table, I would put 0 here as my input. I put negative 9 here as my output. Now we're going to do that a few more times with the same function, but we're going to change what the x value is and what the input is each time. So next, we're going to do f of 1. So it's going to be very similar to what we did up here. We have to evaluate the f function for when x is equal to 1. So my f function is 4x minus 9. So again, instead of x, I'm going to put a 1. So 4 times 1 minus 9. Then I'm going to do the math. What is 4 times 1 minus 9? Well, 4 times 1 is 4 minus 9. 4 minus 9, if you need to use your calculator, you can. F of 1 is equal to 4 minus 9, which is negative 5. So the pair that came out of this is a 1 went into the function and a -5 came out of the function. So 1 is my input, -5 is my output. So if you feel like you have a good grasp of this, now would be a great time to pause the video, try to do f of 2 on your own, check back for the answer, and then do f of 3. If you need to go through it with me, then keep on. If not, pause right now and then come back and check your answer. So f of 2 means I'm going to do 4 parentheses 2 minus 9. 4 times 2 is 8. 8 minus 9 is -1. So f of 2 is -1. So our x value is 2, and when that happens, our y value is -1. So 2, -1. Now, if you feel like you're feeling a little more confident, pause and try f of 3 on your own, and then come back and check it out. So pause now. All right, f of 3, I'm going to do it a little quicker. It should look like this. Then you get 12 minus 9, which is 3. So f of 3 is equal to 3. In this case, the number that I put in is the same number that came out, but if you notice, it didn't work any other time. So it really just depends on your function and what number you're putting in as to what comes out. So all of our inputs and outputs are connected to each other using the same function, 4x minus 9. In your table, sometimes you might see an f of x here, sometimes you might see a y. Either of them are interchangeable, but you need to know how to use the function notation. That's going to be part of your criterion C grade. So if we move down here to this box, take a look at this example. If f of x equals 27, find the value of x. So I want you to think about what's different in this example versus the ones that we did up here. So look how this one looks compared to how this one looks. So hopefully you're noticing that we have this 27 is over there on that side of the equal sign and not in where this little x is. So it's not telling us what x is now. It's actually telling us something different. So if you notice, this f of x equals 27 looks very similar to this up here, f of x equals y, where we're given this 27 and it's actually our y value or our output. So what that means is we have the answer. It says find the value of x, meaning we don't know what x equals. We got to figure that out. What is the x that went in that makes it come out as a 27? So if we write down what our function is, f of x equals 4x minus 9. This 27 is equal to f of x. In our equation, this side of the equation is f of x. So what we can do is replace f of x with 27. So this side of the equation will now be a 27, and that will be equal to 4x minus 9. If I want to figure out what x is, I need to solve using inverse operations. So as we practiced previously, 27 equals 4x minus 9. If I want to solve for x, I'm going to add 9 to both sides. So I'm going to get 36 equals 4x. Then if I want just x by itself, I got to divide by 4 on both sides. So 9 is equal to x, or x equals 9, however you want to say it or see it. So if we were to write our notation now, what we just discovered is that when you have the f function and you put a 9 into it, 27 comes out of it. So this here is a mathematical sentence. What this is shorthand for is a sentence that says the following. I'm going to write on this side since I have room. When 9 is the input for the f function, 27 is the output. So this big long sentence is the words that means the same thing as this little mathematical sentence. So mathematicians like to use notation to simplify things and make them precise, but that is the meaning or the interpretation of this formation notation. So if you see something like f of 9 equals 27, then you know n is the input, gets substituted into the f function, out comes the 27 once you calculate following the function rules. So criterion C, you're going to need to explain things. You're going to need to be able to interpret things. You're going to be able to need to use the function notation. So thinking about it as an input and an output, those are good vocabulary terms. Identifying what it's telling you is helpful as well. So that's going to be part of your criterion C grade. So can you do the problem, whether it's this type of problem using the notation? Can you write the answer as with the notation? Can you interpret the notation? If you see something like this, f of 3, do you know what you're supposed to do with it? Can you follow the notation to the end? So as we're working with function notation and you're working on your CYU, you're going to see the questions can be written a little bit differently, but we need to be able to read and know what it is that we're looking at so we know where to go. So next you're going to need to grab your CYU if you haven't already done that. And your CYU is going to look very similar. I'm going to just pull it up here to get you started. So your CYU here is on function notation. The mild section is just starting with exactly what we were just doing. Looking at these kinds of equations, seeing what it's asking you to find, being able to read this notation so you know where to start, and then to find the answer. If you look at the mild, these are all different functions, so you should practice with as many of them as you can to get comfortable with all different types of functions. When you get to 7 and 8, the function is now what the points that are listed on the graph. So you're using the points to find g of 1 or h of 0. So notice there are points darkened in here on the graph. If you get to the table, same thing. You're trying to find f of 2 using the inputs and outputs that are in the table. When you get to the next page, you have what's called a mapping diagram. I think you'll be able to figure this out. This is showing x, our inputs and our outputs. I would suggest at least doing all of the odd numbers. If you can do all of them, it'd be even better. If you're working quickly, it should be easy. When you get to the medium section, the functions are a little bit different. This one starts out kind of similar, but if you notice, this one has some exponents in it, so make sure you're paying close attention. When you get to the spicy, this is the rest of the medium, it has more graphs. When you get to the spicy section, you're looking at these. Make sure you're reading the problem because they all look very similar, but some of them are asking different. Some of them are like the examples we did up here where you're just putting a number in and getting out what the output is. Some of them are like this one where they're giving you the output and you have to work backward to find the input. So you being able to identify which one's which is going to be really helpful. My suggestion, if you're someone who normally skips to spicy, is that you do maybe all of the odd numbers, at least to make sure you're doing them right before skipping to the spicy section. If you want to get started with the first one here, just hang on for about 30 more seconds. I'll get you set up here. This first one, what you're trying to find is k of -2. Here's your function, k of x. So what we're going to do is we're going to replace all the x's in here with a -2, and then we're going to figure out what does it work out to. So this is how I would set up the first one. And you're going to need to show your work. Oh, all right, let me rewrite the function first. So I'm going to replace all the x's with a -2. So k of -2 equals -3 parentheses -2 minus 2. Then using my calculator, I'm going to calculate what is this when I multiply it, -3 times -2. I'm going to keep this notation on this side. When I multiply these, I get +6, and then I have a -2 on the end. I don't need a calculator for this part. 6 minus 2 is 4. So k of -2 is equal to 4. And that's it. This is your answer because you have that mathematical sentence. When -2 goes in, a 4 comes out. So take a look at the second one. Looks very similar. You're finding h of -4, so use this function. -4 is in the spot where the n would be. Plug in your -4s for all your n's, and then calculate what your output is. Keep working and check back with the answer key. Let me know if you have any questions. Thanks for watching.